Okay, this is where the fun begins. So, what we're going to be doing is starting a new topic, complex or imaginary numbers. This is very key if you're doing A-level further maths. It's the first thing you will be doing if you're doing it in order, and it pops up all over the place. Anyone interested in physics or maths in general, start learning to expect these to pop up all over the place. In fact, even if you are in year 8 or 9, if you're in year 8 or 9, not sure why we're here on a video about complex numbers, but I respect it nonetheless, you may have seen these, probably by accident. So let's boil it down. What exactly are complex imaginary numbers, and why are they popping up all over the place, and why have we actually seen them before? Well, I've got on the board right here a very simple looking quadratic equation, right? X squared plus x plus 1. Looks fairly straightforward. Everything's 1, right? Nothing crazy, no. So, I'm going to ask you to solve this. Hopefully, if you're here, you know how to solve a quadratic equation. If not, come back when you're older. So, we've got options, right? We could factorize it. We could use the quadratic formula. Maybe we could complete the square and graph it, or, many different ways to do it. But let's all try and solve this. So, maybe factorizing it looks a little bit tricky because there's only ones. Put it in the quadratic formula. Do it on your calculator and see what you get. I'll assume you've just paused and done that, as we all do. And I'm going to assume that your calculators have spat out one of two things. They've either spat out a maths error, or they have spat out a weird looking answer with some letters in it. Or they've given you an actual answer, in which case you put it in wrong. They're your two options. And solving quadratics since the age of 12, 13, whenever we start, you've probably put something into your calculator and got a maths error. But you've never really worked out why. Well, this is why. Let's break this down. Let's do the quadratic formula by hand. None of that calculator, handsy-pansy nonsense. Let's just do it by hand. So we know the quadratic formula is minus b, well, b is 1, so minus 1, plus or minus the square root of b squared, which is 1, minus 4ac. Well, a and c are both 1. 4 times 1 times 1 is 4. So 1 minus 4, all divided by 2a. Okay, let's simplify this. So I've got minus 1, plus or minus the square root of 1 minus 4, well that's minus 3, divided by 2. Are we starting to see the problem? The problem is here. I have somehow got myself into a situation I've got the square root of minus 3. Now, if you are below the age of 15, 16, and you ask your teacher, what's the square root of minus 3? They'll say, you can't square root a negative number. Yeah. You may look at that and go, I can't square root a negative number. It's impossible. Well, that's what big maths wants you to think. In reality, we can square root negative numbers. We just have to be a bit fancy with it. So this will give you an error if your calculator isn't on the setting or isn't smart enough to know that we can actually square root a negative number. It will say square root a negative number and it will do exactly what you do up until the age of 14, 15, where you go, can't do it, something's gone wrong. But we are now getting to the point where we realize, actually, we can square root it. And actually, a lot of the time, we need to square root that negative. This is where my complex or imaginary numbers come in. Now, quick caveat. They are called complex numbers. That does not mean they are very difficult. Okay? They are actually quite simple to work with once we get the hang of it. They are also sometimes, slightly different versions are called imaginary numbers. Now, imaginary numbers does not mean these numbers do not exist. I know that sounds, pretty counterintuitive. Imaginary means someone's made them up. They don't actually exist. It's a common joke to say, mathematicians didn't know what was going on, so we made up these imaginary numbers. Also not true, okay? It's the stupidest name ever. They're not imaginary, they exist. We can physically represent them, especially in physics. So don't get caught into the trap of imaginary numbers. Someone made them up, they don't exist. So what are they? Well, an imaginary number is represented by the letter I, little I. Okay, not big I, that's current, that's physics. Little I. And little I will always, always, always be an imaginary number unless you're doing some kind of summation. I'm sure you can actually think of other examples when it's not. But 99% of the time, little I is our imaginary number. And we define little I as the square root of minus 1. This thing that was, impossible, not allowed to do it, can't square root a negative number. We've done it and we've called it I. So the square root of minus 1 is I. Now, we need to be able to extrapolate this out into any other square root of a negative number. For example, the square root of minus 3 from earlier. The way we do that is we use some of our surd rules. This is a surd, more or less, yeah? Even though it's a 1, it's still a surd. And we are going to want to try and express this as the square root of minus 1 times something else. So, how do we simplify within a surd? Or how do we factorize out within a surd? Well, I can say if I have got the square root of AB, it is the same as the square root of A times the square root of B. So, the square root of minus 3 is the same as the square root of minus 1 times the square root of 3. We've accomplished two things here. One, I have now got something with a square root of a minus 1 in it that I can replace with the letter I, because that is the letter I. And I have got a surd that is normal, something that we can compute. The square root of minus 3, 1.7, whatever it is, yeah? This is our goal. Whenever we're trying to find an imaginary number, our goal is to represent the square root of a negative as an I times by something tangible, the square root of an actual real number. So, a couple more examples. So let's say we wanted the square root of minus 7. Well, that is the same as the square root of minus 1 times the square root of 7, which is root 7 times by I. The square root of minus 4, well, that is the same as the square root of minus 1 times the square root of 4, which is I times by root 4, which happens to be simplifiable into 2I. Square root of 4 is 2, that's 2I. These are my imaginary numbers, I, 2I, etc. If you get to this point and your calculator still doesn't know what's going on, I suggest you either get a better calculator or go into the settings and switch it to imaginary mode, okay? Just so that from now on, our calculators can handle this for us. But it's still very important for us to know how to do it now. Ugh. So, that's an imaginary number. What's a complex number? Because they're not the same thing, okay? As many puns as I would like to make about a complex number being more difficult, it's not, okay? It's just slightly different. Let me go back to my example from earlier, where I had x squared plus x, I shouldn't try making jokes, x squared plus x plus 1, and I wrote, obviously equals 0, and I wrote this out as minus 1 plus or minus the square root of minus 3 over 2. Well, I now know that we're no longer calling this a maths error, we're calling this an opportunity. Okay. I'm going to expand this out in the same way I just did, get rid of the negative square root, replace it with an I. So I'm going to split the 1 over 2 out. So I have a half, minus 1, let's just do the plus for now. Obviously we've got to do both plus and minus, but the plus for now, root minus 3. Now, from the last board, root minus 3, I know is I times by root 3. Root minus 1 times by root 3. So it is half times minus 1 plus root 3 times I. And if I expand that, I get minus a half plus root 3 over 2 I. Now, what I've got here is a complex number. Why is this a complex number? It's a complex number because it's got a little bit of everything. I've got an imaginary number here. Root 3 over 2 times by I. That is an imaginary number. But over here, I've got a real number, minus a half. It's real, okay? We've all seen it and used it before, hopefully. It's a real number. So I've got a real number plus an imaginary number. Of course, remembering we do have a plus minus, So we also can't forget, I also have minus a half minus root 3 over 2i, which is my other solution to this equation, and also has an imaginary number, in this case minus root 3 over 2i, and a real number, minus a half. Whenever I have got a real number and an imaginary number added or subtracted together or from one another, it is a complex number. So an imaginary number is my number with an I on its own, these guys here. A complex number are both of them added together. Okay? So this is the bare basics of what a complex and imaginary number are. In the next video, we're going to get on to how to use them, how to conjugate them, lots of fancy sounding words, how to add them, how to multiply them, etc., etc. But what you're going to notice is it's not that much different to just writing an x instead of an I and doing our normal algebra.